want to say that this is 200. V1 is 30 meters per second. This angle here is sine inverse of 4 on 5, which seems awkward at first, but they're actually doing us a favor, as you'll see shortly. This angle here is sine inverse of 3/5. And that's all. This is unknown. Okay. So what they want us to do is find what V2 is. So how do I do that? Assuming these two collide. You have to think about it for a second. Yeah, okay, good. So, given all the information that they provide, and this, which we proved in the first part, okay, I'm going to take this equation, get rid of the rest, because I'm not interested in it. And V2, that second velocity, right, that's the only constant that I don't know the value of. I know what V1, theta 1, and theta 2 are, okay? So therefore, I'll say, since the particles will collide. So I don't want to bring this equation out of nowhere. I want to say, why am I bringing it in? Now, I'm going to take this equation, and I'm actually going to take the values that they supply us, okay? So that looks like 30 sine of sine inverse 4 on 5 equals V2, that's my unknown, sine of sine inverse 3 over 5. Okay, yeah.
Isn't theta 2 180 minus 9?
Okay. No, I don't think so. No?
Because if you, like,
Just based on what they've said. Just based on what they've said. And remember, I'm thinking about it, my x coordinate for the second particle, right? I've slapped a minus on it anyway, which is actually going to do the same thing as sine 180 minus. Does that make sense? So it's going to send me in the right direction, even if I take it as an acute angle. So, okay. Now, on acute angles, that's actually really important to notice, because at this point here, I'm trying to solve for V2, right? Now, your next line probably you think, oh, well, sine of sine inverse, that'll just be 4/5, right? So you write 30 times 4 over 5 over here on the left-hand side, which is correct, okay? But how much do you remember of inverse treating? I can't simply say that sine of sine inverse something is something. Why not? Why can't I just say that it is? What am I missing? When you do sine inverse, right? This only works for certain values, right? Sine inverse doesn't go forever. We restrict it in a certain place, right? Now, when you come to here, why can I just take this value and not come up with some other one? It's because I have some restrictions on theta 1 and theta 2. Namely, that they're both acute, okay? Because if they were obtuse, they would fire off in another direction, different from what the question is defined. And if they were reflex, they would be blowing themselves up because they're firing at the ground, okay? So, I can simplify this part out, and also the right-hand side. But the reason I can say that is because I know, not inclusive, I know that these angles are acute, okay? And that's an important thing not to miss, okay? That's why I can simply cancel this out, right? If it wasn't, if these angles were, say, obtuse or reflex in some other kind of situation, then this is not going to be quite so neat. Okay, but we'll deal with that later. Now here it's just a simple result. V2 equals, multiply that through. Because the result is known, I'm not just going to write down V2 equals 40. I'm going to put this over here so that you can see where my working is. So that's why I can cancel, cancel. Now I can say 40. Okay, always provide more lines of working when they provide you the result. All right, show that, and that the particles collide after 4 seconds. Okay, so I know what this second speed is now. You remember that what's confusing, one of the things that's confusing about this topic is that there are so many different equations flying around. Which one should I go to in order to show that the particles collide at a certain time? Where would you go? Have a look at your equations that you've got written down. Oops.
Go back to your x equations.
Yes. Okay, now, why go back to my x equation? Okay, I could go back to my y equation, right? Couldn't I? My x equation's a better choice. Why?
More simple.
Okay, number one, it's simpler. Number two, right? It's still got, after simplifying it out, it's still got a t in it, right? When we took our y equation and we just slapped them together, the t disappeared. Okay. Well, that's kind of not a very good place to go for number one because no t in it. Number two, it's where I came from. I'm just going to get, 50 equals 50. Woohoo! First prize. 0 marks, okay? So don't do that. Go back to your x equation, right? Particles collide when? Okay, so here's the equation that I would write. V1t. Oops, sorry. Okay, so you can see now where my AB has come in. Here it is, right? And now the rest of it is just subbing stuff out. Now you have to be careful because of this cosine here, but let's have a think about how this is going to work out. V1 is 30t cos of sine inverse. Be careful. 4 over 5 equals 200 minus, get out of the way, 40. Okay, now, again, I'm going to evaluate this in a second. And again, just like before when I got rid of my inverse trig functions, I have to note that these angles are acute. But how do I get rid of these when I've got cos and sine inverse together? What do I do? Yeah, good, draw a triangle. Now, 4 over 5, maybe at this point you're like, oh, I know what kind of triangle this is. It's just a 3, 4, 5 triangle, right? That's terrible scale. Sorry, you get the idea. So sine inverse 4 and 5, which angle is that in this triangle? It's this one over here in the corner, right? So cos is adjacent and hypotenuse here, okay? So this part here, 30t times, instead of 4 over 5, it'll be 3 over 5. That's all. See how it's gone to the other ratio? This will be 200 minus 40t times, and this will work exactly the same way, but in reverse, okay? All right, now, where are we at? I think you can simplify from here. You're gonna land on t equals 4. Okay, you satisfied with that? It's not that hard afterwards.